Okay, welcome to the Right Triangle Trig podcast. So we've been doing a lot with trig functions and the unit circle, but now we're going to start using right triangles in trig functions and see how they're related. So this part should be review. If we have a right triangle, so this is our right triangle, and we choose an angle on that right triangle that we call theta, there are three sides relative to that angle. The opposite side, because it's opposite theta, our hypotenuse, and our side adjacent to theta. Sorry, excuse that line. Okay. And our trig functions, in terms of those three sides, we have sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Okay, so those three are the most fundamental trig functions. And then we have their reciprocals, cosecant, which is the reciprocal of sine, so it's hypotenuse over opposite. Secant, which is hypotenuse over adjacent. And cotangent, which is adjacent over opposite. Okay, and remember, these are reciprocals of each other. Okay, so let's do an example here, and this example, again, should be review. If we have a right triangle, we'll call this angle theta, and our side lengths are 8, 6, and 10. Our opposite side length is 6, our adjacent side length is 8, and our hypotenuse is 10. Let's evaluate cosine theta. So cosine theta, if we look up here at our trig functions, is adjacent over hypotenuse. So adjacent is 8 over a hypotenuse of 10, and that simplifies to 4/5. Let's do one more. Let's do cotangent of theta. Cotangent is adjacent over opposite. So that's 8 over 6, which equals 4/3. So that should all be a review for you. Okay, so you've evaluated the trig functions of 45 degrees, 30 degrees, and 60 degrees using the unit circle, but let's see what that looks like for right triangles. So we're going to start with the triangle on the left, and we're going to make this a 45, 90 triangle. So 45 degrees, and there's our right angle, and we're going to make the legs equal to 1. And using the Pythagorean theorem, you can calculate that the hypotenuse equals the square root of 2. So let's let this 45 degrees equal our theta. And let's evaluate sine of 45 degrees. So we know that sine of theta equals opposite over hypotenuse. So sine of 45 degrees equals, the opposite is 1. So 1 over our hypotenuse, the square root of 2. But we can't have a square root in the denominator, so we have to multiply by 1. Square root of 2 over the square root of 2 equals 1. And we get the square root of 2 over the square root of 2 times the square root of 2, which is the square root of 2 squared. So that equals 2. Okay. Let's calculate the cosine of 45 degrees. Cosine equals adjacent over hypotenuse. So our adjacent side is 1 over our hypotenuse of the square root of 2. And again, we have to multiply by the square root of 2 over the square root of 2. And we did that above. So it's the square root of 2 over 2. And tangent of 45 degrees. Tangent is opposite over adjacent. So our opposite side is 1 and our adjacent side is 1. That equals 1. Okay, now let's look at the triangle on the right. This triangle is a 30, 60, 90. So go ahead and write those down. We're going to let this first leg equal 1. Our hypotenuse is going to equal 2. And then using the Pythagorean theorem, you can find that this leg equals the square root of 3. So first, let's calculate the sine of 30 degrees. So sine is opposite over hypotenuse, and opposite is 1. Our hypotenuse is 2. That one was easy. Cosine of 30 degrees. Cosine is adjacent over hypotenuse. Our adjacent side is the square root of 3, and our hypotenuse is 2. The tangent of 30 degrees. Remember, tangent equals opposite over adjacent. So opposite, we have 1, and adjacent, square root of 3. We cannot leave the square root of 3 in the denominator. So let's multiply it by 1. 1 over the square root of 3 times the square root of 3 over the square root of 3. And that gives us, there we go. Now let's do the sine of 60 degrees. So now we're looking down there at 60 degrees. Sine of 60 is opposite over hypotenuse. Opposite is square root of 3. Our hypotenuse is 2. The cosine of 60 degrees is adjacent over hypotenuse. Our adjacent side is 1 and our hypotenuse is 2. And our tangent of 60 degrees, tangent is opposite over adjacent. Opposite is the square root of 3, adjacent is 1, so that's just the square root of 3. Okay, now, do you see any of these functions that are the same? Are any of these the same? There are some that are the same. Let's write these out here. Sine of 30 degrees equals cosine of 60 degrees. And both of those equal 1/2. We also have sine of 60 degrees equals cosine of 30 degrees. And those ones equaled the square root of 3 over 2. And if you look over at the first triangle we did, sine of 45 degrees equaled cosine of 45 degrees, which equaled the square root of 2 over 2. And that leads to an important rule. Write this down. Cofunctions of complementary angles are equal. And cofunctions, sine and cosine are cofunctions And the complementary angles are the 30 degrees and the 60 degrees. Those add up to 90, so they're complementary. And same with the 45 and 45. Those add up to 90 degrees and they're complementary. Okay, so the reason we spent so much time on these angles with these trig functions are because these 30, 45, and 60 degree functions occur a lot in trig. So you should learn how to construct these triangles and readily know that tangent of 45 degrees equals 1, for example, or the sine of 30 degrees equals 1/2. That's going to help you a lot in trig to know those. So let's do an example of solving a right triangle. But before we do that, there's some important vocabulary you need to know. So if this is somebody looking out, this is the horizon. If they're looking up from the horizon, that angle is called the angle of elevation. If they're looking down at something from the horizon, that's called the angle of depression. So if they're looking up from the horizon, the angle of elevation, and if they're looking down, it's the angle of depression. So let's look at an example that applies our trig functions. So it says a historic lighthouse is 200 yards from a bike path. So let's make a little bike path here. Here's our lighthouse. So this distance is 200 yards. Okay. A walkway from the bike path to the lighthouse is 400 yards long. So we'll let this be our little walkway. And that's 400. So it forms, there's a right triangle there. And it asks, what is the angle between the bike path and walkway? So it wants this angle here. Now, relative to this angle, what side lengths do we know? We know opposite and we know hypotenuse. And now we have to think, what trig function do we have that relates our opposite side with our hypotenuse? And you should recognize that that's sine. So let's write that out. Sine of theta equals opposite over hypotenuse. Let's plug in our knowns. Okay, and that equals 1/2. So sine theta equals 1/2. And you should recognize that theta has to be 30 degrees. From all of those examples we just did, and even from our unit circle examples from before, you should know that sine of 30 degrees equals 1/2. So the angle between the bike path and the walkway, 30 degrees. Okay, now let's talk about trig identities. What we're going to write down are some fundamental trig identities, and trig identities are relationships between the different trig functions. So write these down with me because we're going to be using them in the next example. So reciprocal identities, sine theta equals 1 over cosecant theta. That's our first one. And from there we can derive another one. Cosecant theta equals 1 over sine theta. So those are two different reciprocal identities. Cosine theta equals 1 over secant theta. And from that one, we find that secant theta equals 1 over cosine theta. And these are called reciprocal identities because sine theta is the reciprocal of cosecant theta, and cosine theta is the reciprocal of secant theta. And our fifth one here, tangent theta equals 1 over cotangent theta. And I bet you can figure out this one. Equals 1 over tangent theta. Okay, now let's write down our quotient identities. Tangent theta equals sine of theta divided by cosine of theta. And cotangent theta equals cosine theta over sine theta. Now, let's write down our Pythagorean identities. Sine squared theta plus cosine theta squared equals 1. 1 plus tangent theta squared equals secant squared theta. And 1 plus cotangent theta squared equals cosecant theta squared. And something to note is that this sine squared theta, that's how we write it in trig, but that's equal to sine of theta squared. But when we write it out, we write the squared, we write the exponent between sine and theta. Okay, so make sure you know that that's true, that this is true. Okay, I'm going to star, let's see if I can get a different color here. Yeah. These identities that I star, you should definitely know these identities. Those are the 5 most common, is the sine theta, the cosine theta, the tangent theta. This quotient identity is really important, and so is this sum of sine squared theta and cosine squared theta equaling 1. So those ones you should definitely know. Those are very important and very common, and you'll find that we use them a lot soon. Okay, so how do we apply these trig identities to trig? Here's an example. If sine theta equals 0.6, find the values of cosine theta and tangent theta using trig identities. So, let's write down what we know. I'm going to go back to my black pen here. So this sine theta equals 0.6. That's given information, okay? And what trig identity, look at the trig identities you just wrote down and see if you can find the trig identity that relates sine and cosine. If you found this one, you were right. So this is our trig identity. Okay, so we know that sine theta equals 0.6, so let's plug it into our trig identity. So 0.6 squared plus cosine squared equals 1. So 0.6 squared, well, first let's do this. We want to get cosine theta by itself here, so. Okay. And that equals 0.64. 1 minus 0.36 equals 0.64. So now we have cosine theta squared equals 0.64. So now, how do we get cosine theta by itself? Well, it's squared, so let's square root it. And that leaves us with cosine theta equals 0.8. Okay. Now, the second part of our question asked us to solve for tangent theta. Well, we know that sine theta equals 0.6, and we know that cosine theta equals 0.8. So look at your trig identities again and see if you can find an identity that relates cosine, sine, and tangent. I'm going to give you a second to do that. Okay. You should have found this one, tangent theta. It's one of the quotient identities, equals sine theta over cosine theta. Okay. So let's use those values I circled. Those are knowns. Sine theta equals 0.6 and cosine theta equals 0.8. So that leaves us with tangent theta equals 3/4. Okay, so if we were to apply all of this and think about a triangle to check our answer, let's draw a right triangle. Okay, we were first given that sine theta equals 0.6. So let's choose this angle here. How would we make sine theta equal 0.6? Well, sine theta, remember, is opposite over hypotenuse. So our opposite could be 0.6 and our hypotenuse could be 1. And then 0.6 over 1 equals sine theta, which is 0.6. So that works. And then cosine theta is adjacent over hypotenuse. So this could be 0.8 over 1. And that equals 0.8. So that one works. And then tangent. Let's see if tangent of theta would work. Tangent of theta is opposite over adjacent. So 0.6 over 0.8. And that's what we got here. So that one works as well. Okay, so we'll be doing some more applications of trig identities in class. So start memorizing all of those values of sine of 30 and sine of 45 and cosine of 30 degrees, and start memorizing those and start getting to know those trig identities. We'll see you in class.